Okay, good morning, everyone. Okay, my name is Hong Jun Kim, and I'm the professor to teach the calculus. And okay, so let me show you the material I prepared, and then we can continue. Okay, so okay, okay, okay. Okay. So this is the calculus with lab one, this class, and session 25. And this course is a synchronous online class meeting through Zoom on Mondays and Wednesdays. On Mondays, our class starts at 9, and then we have a break from 10:15 to 10:30, and then we have the second class starting at 10:30 till 11:20. So the second class on Monday will continue only for 15 minutes. Okay? And then on Wednesday, we have classes from 9 to 10:15. So on Mondays, we have the first class starts at 9, ends at 10:15, and then we have a 15-minute break. Then the second class starts at 10:30 and continues till 11:20. So that's the timetable for Monday. And on Wednesdays, we have classes from 9 to 10:15 in the morning. Now, those are for regular lectures. The exam will be held in person, offline exam will be provided. Okay? And I will let you know the exact dates for the exams. The location of the classroom will be Hana Science Hall, room B214. That's okay. I will announce that information before the exam one more time. But anyway, the exam will be held in person. Okay, so you have the offline exam. So at that point, we will see each other. Okay. And this is my information. And if you have any question, complaints, suggestions, or anything, please email me. My first name at korea.ac.kr is my email address. So if you have any questions, please let me know through the email. And this is, as you probably know, the Calculus 1, the introductory course. Okay, we will consider the functions and many properties of the functions, including limits, differentiation, integration, and their applications. But we will consider only single variable functions. And in the second semester, in the fall, you will consider multivariable calculus. But in the spring, we will consider only single variable case. So after you complete this course, you should be able to demonstrate a thorough understanding of the topics listed in the previous slide, like differentiation, integration, limits, and so on. And you should be able to solve many problems related with those topics. Okay, and also you should be able to apply those concepts to real world problems in your research fields. Our textbook is the Calculus textbook written by James Stewart. And actually, he wrote many textbooks, and the textbook we are going to use is Calculus Early Transcendentals. And there are many editions. Okay. But any edition will be fine. Any edition. Even the US edition will be fine in our class. Okay. So any edition of this under this title written by James Stewart will be okay, used can be used as a textbook. And here is the my plan. Okay, here is the outline of the class in this semester. Okay, so our class will continue for 16 weeks. So after 7 weeks, we will have the midterm, and the midterm will be given on just a second. Let me see. Oh, sorry. This is not 23rd, but April 21st. Sorry about that. Let me correct the material. So April 21st, okay? Not 23rd. That is Tuesday. And then the final exam will be given on, oops, sorry about that. We have classes on Wednesday, right? So sorry about that. This is not the corrected day. It is, sorry about it, not 23rd, it is a Thursday, 22nd. That is Wednesday. And June 17th, that is also Wednesday. Okay, so we'll have the midterm on April 22nd. Okay, April 22nd, which is Wednesday, and we will have the final exam on June 17th, which is also Wednesday. And I will correct this file and then re-upload this file on the LMS website. Sorry about the inconvenience. So we will have the midterm on April 22nd. And target audience, well, actually, this course is designed for students from various departments, from math, physics, engineering, or even economics, or say linguistics, humanities, okay, all various departments. And I don't think any prerequisite is required for this class. So as long as you understand high school algebra and high school trigonometry, those will be sufficient. So there will be two exams, as I said. Okay, so April 22nd and June 17th. June 17th, yes, both are Wednesday. And each exam is worth 45 points. And the exam will be held in person in, as I said, in Hana Science Hall, room B214. It is in the basement. Okay, please do not go to the second floor. The classroom is located in the basement of that building, and the attendance is essential as missing lectures will hinder your ability to keep up. So I assigned 10 points for the attendance, and your grade will be determined through the absolute evaluation. So out of 100 points, if you get 95 or more, you get A plus. And if your grade is less than 95 but greater than or equal to 90, you get A, and so on. Here is the policy regarding the attendance. The attendance will be checked automatically through LMS and Zoom. Okay. And if you attend the each class more than 90 times, so if you attend more than 90% of the class time will be regarded as attended. But if you miss more than 10 points, 10%, but less than 50% of class time due to joining late or logging off early, then you will be marked as a tardy. But if you miss more than 50%, that will be recorded as an absence. And if you make 3 tardies, those will be counted as a single absence. Okay. So if you make, say, 3 tardies or 6 tardies, that will be counted as 2 absences. Now, if you make fewer than 3 absences, you get 10 points. If you make 3 to 6 absences, you get 8 points. If you make more than 6 absences, you get 5 points. Okay, but please note that it is official university policy to assign an F grade to any student who misses 1/3 or more of the total class sessions. So even though I can give 5 points if you absent, say, 20 times, in that case, you will get an F automatically. So please be careful. If you have a physical, psychological, medical, or learning disability that may impact your coursework, please let me know. Okay, I will determine with you what kind of accommodations are necessary and appropriate. And of course, all the information and documentation you provide will be confidential, and those will be destroyed right after I check. And of course, I do not share that information with anyone. So for the procedure and information, please let me know through the email. Okay, anyway, so this is the outline of the class. And before we jump into the main part, let me explain about the online attendance. Okay, so oops, um, yeah, okay. So if you when you join the class, probably you already read this announcement. Okay, now when you join our class, please change your Zoom display name. Okay, I have many students in this class and I cannot check the attendance manually. So I will run the program to check the attendance automatically. So please change your Zoom display number with your student ID number. Okay. So for example, if your name is Gil Dong Hong and if your student ID number is 123456, then please use only this ID number as your display name. Other formats like your name or combination of the student ID number with your name are not allowed. So if you mix this information, I cannot check the attendance. So starting next time, not today, okay, you don't have to change the name today, but starting next time, please change your display name, okay, to your student ID number. Please do not use your name, okay, or please do not use your nickname, or even the mixture of those. Please use just the ID number only so that I can run the program. Now, once you log into the LMS website, this mylms.korea.ac.kr, on the left hand side, you have weekly learning. So please click this weekly learning. If you click it, then you will find many links for the classes. So click the link corresponding to the date of the class. The links are formatted as month.day format. So for example, for today's class, which is given on March 4th, you need to click 3.4 on the week 1 session. And on Monday, we have two classes. So since there are two classes on Mondays, you will find two separate links formatted as month.day.1 and month.day.2. So for example, for March 9th, there will be two links, 3.9.1 and 3.9.2. Please click the corresponding link, and then you need to click Start a Video Meeting to enter the session. If you click this button, then your attendance will be recorded and checked automatically. And your attendance can only be properly recorded if your Zoom display name is set exactly to your student ID number as instructed in step 1. So please be mindful of this requirement. So if you click weekly learning, you will see some links here. So if you click 3.4, that is today's class. And 3.9.1 is for Monday, the Monday class, the first class on Monday. And 3.9.2 is the second class on Monday. And if we click 3.11, that is the link for the March 11th. So if you click this link on March 11th, and if you click this join a video meeting, then your attendance will be checked. So that it will be the procedure to join the online class. And for today's class, yeah, this is the today's class. So yeah, anyway, that is the announcement for the today's class today regarding these lectures. And if you have any questions, please let me know through the email. Okay. Anyway, that is the some announcement, and let's go to the main part. Okay. So usually in calculus class, we do not cover first few chapters, but I want to point out a few definitions. So I will go a little bit fast for the first two chapters, chapter 1 and chapter 2. And then probably starting chapter 3 or chapter 3, I will go a little bit, I will slow down a little bit, and then yeah, I will explain in detail starting chapter 3. But in chapter 1 and chapter 2, probably in most countries, chapter 1 and chapter 2 were covered in high school days or even in middle school days, I guess. So I will go fast to brush up those definitions. And then starting chapter 3, I will point out some important theorems or definitions. But anyway, let's consider chapter 1. Okay. First. Okay. So okay, so let's consider chapter 1. In chapter 1, we want to consider the definition of a function. So what is a function? Function is a mapping. It is a rule that assigns, okay, when we consider a function, we are given two sets, say set D and set E. Given two sets, function f is a mapping. It is a rule that assigns to each element x in one set, say D, exactly one element in a set E. And this corresponding element in E will be denoted by f of x if the function is named f. And this set D will be called domain, and set E will be called codomain. Now, within this codomain E, some elements are mapped by some elements in D. So the number f of x in E is called the value of f at x. And if I collect all the possible the values of f of x, then that collection will be called the range of the mapping. Okay? So that is the definition of a function, domain, codomain, or range. And this x is called an independent variable. And f of x, the value, is called the image of x, or the value of x. Value of f at x. I'm sorry, the image of x. Yeah, the image of x. So the range is, in other words, the collection of all the images. So that's the meaning of the range. Now, given some curve in the xy plane, some curve represent the graph of a function, while some curve does not represent the graph. And one simple technique, some simple test to check whether this given curve is the graph of a certain function is the vertical line test, which says a curve in the xy plane will be the graph of a function of x if and only if no vertical line intersects the curve more than once. So as an example, given this curve on the left, when I consider any arbitrary vertical line, the vertical line intersects at only one point. So this curve is just will be a graph of some function. But for the curve in B on the right hand side, some vertical lines intersect, okay, at a single point. But if I consider this red line, then this red line intersects the curve at 2 points. So if there is any such line, any such vertical line intersecting the curve at more than 1 point, then the given curve does not represent a function. So this is called the vertical line test. Now, given a function, some functions are special and satisfy this property for any x in its domain. I mean, when you plug in x and negative x, you get the same values. If your function satisfies such a property, then your function is called an even function. So for example, the x squared function is an even function because when you plug in negative x and x in place of x, you get the same value, same image. So in other words, negative x and x have the same image. So if your function is an even function, as you can see in figure 19, the graph will be symmetric about the y-axis. So that is one property of an even function. Some function satisfies, on the other hand, this property. So for example, if I consider x cubed function, when you plug in negative x in place of x, you get negative 1 times x cubed. So that is the negation of f of x. So if your function satisfies that property, then such a function will be called an odd function. So x cubed function is an example of an odd function. And in case of an odd function, the graph will be symmetric about the origin, as in figure 20. So those are some properties of So some definition and properties of the even and odd functions. And sometimes your function satisfies this property. So whenever you consider two values in the domain, okay, and I mean in some interval, okay, the domain is given as the interval, like this or this. Anyway, in this interval, when you choose two values, say x1 and x2, and whenever x1 is less than x2, if the image of f of x, image of x1 is less than the image of x2, or in other words, the value of f at x1 is less than the value of f at x2, whenever x1 is less than x2, in that case, the function is said to be an increasing function. And if you have the opposite direction, in if the f of x1 is greater than f of x2, whenever x1 is less than x of 2, then we say the function is decreasing. So those are some special types. The even or odd functions, increasing or decreasing functions are some special types of the functions. And in this section, we just reviewed the basic definitions of those special, the function and some examples. Okay. And I think you know this concept. You probably considered this in high school days, I guess. Now, some function, in some case, we say y is a function, but sometimes we call that function as a linear function if the function is given by this form. Here, m and b are some constants. So given some fixed numbers m and b, if your function is defined by this type, then we say this function is a linear function of x. And graphically, if your function is a linear function defined by mx plus b, then b is the y-intercept. That means when I consider the graph of the linear function, the this graph of the function intersects the y-axis at b. And then this m represents the slope of the line. Then that means when your x increases by 1 unit, your corresponding y increases by m units. Anyway, so that type of a function is called a linear function. But sometimes your function may be defined in this form. Here, a sub n, a sub n minus 1, a2, a1, a naught. These are some numbers. And I have x to the n, x to the n minus 1. These powers of x appear. And this a naught, a1 up to an, these are called the coefficients of the polynomial. And if a sub n is the coefficient of the polynomial, where n is the largest power with non-zero coefficient, then this n is called the degree of the polynomial. So if I consider this polynomial, then since this 2 is the coefficient, non-zero coefficient of x to the 6th, that is and this 6 is the largest power of x with a non-zero coefficient. So this p will be the polynomial of degree 6. And in case of the polynomial, the domain is the whole real lines. Okay, there is a typo. So the whole real line will be the domain of any polynomial. And when the degree of the polynomial is 1, your polynomial will be of this form, and that means your function, your polynomial will be a linear function. If your polynomial has a degree 2, as in this, then we call such a polynomial as a quadratic function. If I have a quadratic function, then the graph of a function will be given as a parabola, as in figure A or in figure 7. So given this ax squared plus the bx plus the c type quadratic functions, if a is greater than 0, then you have the graph as in A, and if A is negative, then the graph will look like that in B. So those are some examples, some the graphs of such quadratic functions. If your polynomial has a degree 3, then that polynomial will be called a cubic function or cubic polynomial. And in that case, the graph will look like those in figure 8, but there may be some different variation. Okay. But anyway, so those are the graphs of a cubic function, cubic polynomial. Oh, and if your function is of this form, x to the a, please note that this x is a variable and a is a constant. If your function is given by this x to the a type, then such a function is called a power function. And we want to consider several cases when this a is a positive integer, as in 1, 2, 3, or 4, then you have a linear, quadratic, or cubic functions. I mean, you get a polynomials of only single term. If a is 1 over n, where n is a positive integer, then you have a root function. So for example, when n is a 2, then you get x to the 1/2 power, which will be the same as the square root of x. So that will be the square root function. And for that function, the domain is the non-negative values. Okay. And the graph will be upper half of the parabola, as in figure 13a. Oh, and in case of the first one, when a is n for some positive integer, as I mentioned, this is a special type of a polynomial, so the domain will be whole real line from minus infinity to infinity. If n is an odd number, like 3, then you get the cubic square root function, which is defined on whole real line. So domain is the whole real line. Please be careful. So when and the graph will be similar, will be given as in figure 13b. So the function is defined for any x. So that will be the shape of the graph for the cubic square root function. So In case of the when n is equal to 2, then the domain is non-negative values. But when n is a 3, you can consider the cubic square root function for any x. Now, when n is a 4, then you have a similar situation to the square root function. I mean, if your n is any even number, even integer, then the graph of this will be similar to the graph of the square root function, and the domain is the same, non-negative values. When n is an odd number, then the graph will be similar to that of the cubic square root function, and of course the domain will be the whole real line. When a is negative 1, then x to the negative 1 will define this 1 over x function, which is the reciprocal function, and that is defined on whole real line except 0. So the domain for the reciprocal function will be negative values and positive values except 0. The function is not defined at 0. And the graph will be a parabola as in figure 14. So those are some special cases of power functions. Okay, we just considered the polynomials and power functions, and when you divide one polynomial by another polynomial, then the resulting function will define a function called a rational function. So, rational function is a function defined by dividing one polynomial, say p, by another polynomial by q. Now, as I said, the polynomials are defined for any x, for any real value. So the domain of p and the domain of q will be the whole real line. But as we know, the 0 cannot be in the denominator. So when I consider this rational function, the denominator is not assumed to be 0. In other words, the domain consists of all the values of x such that qx, the denominator, is a non-zero valued. So for example, if I consider this 1 over x function, that is a very simple rational function because the numerator is a constant value 1 while denominator is x. The domain will be just whole real line except the 0. Okay. So that is called a rational function. Please remember the definitions of those. Okay. Now, given some functions, sometimes I can construct another function from the known functions by performing some algebraic operations. So when I say an algebraic operation, it means an addition, subtraction, multiplication, division, or taking a square root or any root. So for example, given a polynomial, okay, so when I say an algebraic function, I should start with polynomials. Okay, so starting polynomials, say x squared plus 1. If I take the square root, you get an algebraic function f. Or if you consider the square root of x, that is obtained by taking the square root, okay, for x function, and then if you add x, you get some algebraic function. And if you divide one polynomial by another algebraic function, that will be also on the algebraic function. So these are all examples of algebraic functions. Now I guess you learn trigonometric functions in high school days. So I expect, I assume that you know what a sine function or cosine functions are, right? And there are sine, cosine, tangent, and the cosecant, secant, and cotangent functions. So those are some trigonometric functions. So I will assume that you are familiar with these functions. Otherwise, let me know. And in our class, we will use the radian measure instead of the degree measures. So, so when I say sine pi, then this pi is the angle defined in measured in radian. So that will be 0. Okay. So we are going to use this radian. So here are the graphs of sine and cosine. So the values of sine and cosine are bounded between -1 and 1. The values are periodic, right? Every 2 pi you get the same value. And sine function starts from 0. Cosine function starts from 1. In section 1, I called the sine we defined on. Okay, when you look at the sine graph of sine function, the graph is symmetric about the origin. So this is an example of an odd function. And in case of cosine, the graph is symmetric about the y-axis. And such a function was called an even function. So cosine negative x and cosine x will have the same values. But in case of sine, sine negative x will be negative 1 times sine x. So those are some properties of sine and cosine. And they are periodic, meaning sine x plus 2 pi will be the same as sine x. And cosine is also a periodic function. And there are many other properties for sine and cosine. But anyway, given this sine, and as I said, their domains are the whole real line, and the range is the closed interval between -1 and 1. The values are limited between -1 and 1, and these two functions are periodic functions. So when I say a periodic, we say a function is periodic if there exists some positive value p such that f of x plus p equals f of x for all x in the domain, then we call such a function as a periodic function. And the smallest positive p in that case will be called the period. So in case of sine and cosine, the periods are 2 pi. The tangent function is defined by dividing sine x by cosine x. And in case of a tangent, it will be a periodic function, but the period is just pi. So it is a periodic with period of pi. And this function tangent is defined by sine over cosine. So when cosine is zero valued, the tangent is not defined. So the domain of the function does not include 2 pi or 3 pi half and pi half or 3 pi half and so on. So at those points, cosines are zero and the tangents are not defined. Okay, and yeah, of course, tangent is an odd function. It is symmetric about the origin, so it is an odd function, right? So those are some definition, I mean, some properties of the trigonometric functions. And if you have a question, please let me know. You can send me the chat message, or you can. Okay, I do not check the email during the class. So if you have any question, you can email me, then I can answer next time. Okay, now I want to consider something called the translation of graphs. And this is important, okay? Even though you probably studied this concept in high school days, let me brush up this topic. Suppose that C is some number, positive number. And suppose that I know the graph of f of y equals f of x. So suppose that I have the graph of f of x. This graph is given. And if I want to find the graph of y equals f of x plus c, then you need to move the graph of the original f function upward by c units. So you need to move this, okay? You need to shift the graph upward by c units. So if you move the graph upward, then you get the graph of y equals f of x plus c when c is positive, of course. When you have if you want to draw the graph of f of x minus c, then you need to shift the graph downward. Then you get the graph of the y equals f of x minus c. So if you have the graph of y equals f of x, and then if you add c or subject to c from f of x, then you need to shift the graph upward or downward. Sometimes, instead of adding or subtracting some number, x is replaced by some x minus c or x plus c in f. In that case, so suppose that, yeah, do I have, yeah, right. Okay, so suppose that I have the graph of y equals x squared. And if I want to draw the graph of x squared plus 1, you need to shift the graph upward by 1 unit. If we want to draw the graph of x squared minus 3, you need to shift downward by 3 units. And instead of adding or subtracting some number, if your x is replaced by, say, x minus 2 squared, in that case, you need to shift the graph of f of x to the right by 2 units. So if you have minus 2, then you need to move your graph to the right 2 units. If if you want to draw the graph of x plus 4 squared, so if you have a plus 4, you need to shift the graph of the original function to the left by 4 units. So that's how we transform the graph of the function horizontally or vertically. Okay. So when the f of x is added or subtracted by some units, or x is replaced by x plus c or x minus c, you need to consider vertical or horizontal shift. So based on this, so as I show, I mean, as I showed, I could draw the graph. I showed the graph of y equals x squared moments ago, which was a parabola like this. So if I know that, I can now draw the graph of x squared plus 1, x squared minus 3, or x minus 2 squared, x plus 4 squared, and so on. So for example, if I have, say, if I have y equals x squared plus 4x plus 1, then x plus 2 squared minus 3. So I know the graph of y equals x, sorry. So if I know the graph of y equals x squared, then I can draw the graph of y equals x plus 2 squared, which will be obtained by translating the graph of the x squared to the left. So that is the graph of y equals x plus 2 squared. And then due to this negative 3, if I shift the graph downward by 3 units, okay, then that will be the graph of y equals x plus 2 squared minus the 3, which is x squared plus 4x plus 1. So I can draw the graph of this function if I know how to draw the graph of y equals x squared by combining these vertical or horizontal shifts. Sometimes, so we need to consider stretching or, you know, reflect shrinking. So sometimes some number c is multiplied to f of x. So for simplicity, let me assume that this c is greater than 1. In that case, when such a c is multiplied to f of x, then you need to stretch the graph vertically by a factor of c. But if you multiply some number which is less than 1, so if c is greater than 1, 1 over c will be less than 1. In that case, you need to shrink the graph vertically by a factor of c. So for example, if I have the graph of f of x like this, and then if you multiply, say, 2 times of f of x, then you need to stretch the original graph by a factor of 2. But if you consider, say, the graph of y equals 1/2 of f of x, then you need to shrink the graph. Okay. Now, sometimes if instead of x you multiply c to x inside the inside the f function, then so if c is multiplied to x, then you need to shrink the graph of f of x horizontally. Okay. And so for example, if this is the graph of y equals x squared, and if you want to draw the graph of, say, y equals, say, 2x squared, then you need to shrink the graph horizontally by a factor of 2. So that will be the graph of y equals 2x squared. If you have y equals f of x over c, when c is greater than 1, you need to stretch the graph horizontally by a factor of c. So for example, if I want to draw the graph of, say, x over 2 squared, then you need to stretch the graph by a factor of 2. So as a special case, and when you multiply -1 to f of x, then you need to reflect the graph about the x-axis. And when x is multiplied by -1, you need to consider the reflection about the y-axis. So when this is the graph of f of x, if you consider the graph of f of -x, then you need to consider the reflection about the y-axis. And if you consider the graph of y equals -f of x, then you need to consider the reflection about the x-axis. So by combining these stretching, shrinking, or vertical or horizontal translation, you can draw the graph of almost any function you encounter in the calculus class, I guess. So this is not that difficult. I mean, this slide, the transformation of a functions vertically or horizontally, or these are quite useful techniques. So, okay, just a second. Okay. So, as I said, if you have the graph of, say, cosine function, if you multiply 2 to the cosine, you need to consider the stretching vertically. If you multiply 1/2 to cosine, you need to shrink the graph vertically. And if you consider cosine half x, then you need to stretch horizontally. And if you consider cosine 2x, you need to consider the horizontal shrink. So you need to, I mean, these techniques are quite useful. I mean, in calculus class, I'm not spending much time on graphing, but if you can draw the graph of a function in our calculus class, you can solve many problems easily. Okay, even limits, differentiation, integration, and or their applications. If you can draw the graph of a function, you can solve many problems, really many problems easily. So practicing this drawing a graph is one way to improve the skills in calculus. Sometimes we can take the absolute value of a function. So if you consider this function, so y is defined by the absolute value of some function f of x, then as we know, the absolute function will give you non-negative values. So whatever you have inside this vertical line, if the value inside the vertical line is non-negative, you get the original value as it is. But if the value is negative value, then you need to convert it to the positive value by multiplying -1. So if f of x is non-negative, then the function will be just f of x. But if your function is negative valued, then this absolute value will return the negative f of x. So when I have some graph of a function f of x, And if you take the absolute value, then these positive values are not altered by the absolute value sign, but these negative values will be multiplied by negative 1. So given this blue curve, that is the graph of f of x, the absolute value of f of x has the graph as in red. And as we constructed algebraic functions from polynomials, sometimes we can combine, we can define a new function by performing some arithmetic operation with two known functions. Or in other words, given two functions, say f and g, I can define f plus g, which is a function which maps x to a certain value, and that certain value is the sum of f of x and gx. And f minus g is defined in a similar way. And similarly for f times g and f over g. Now, then what will be the domain of such a function? What will be the domain? Well, in order for f of x plus gx to be well defined, this expression f of x and gx must be meaningful. So, f plus g is defined only when both f of x and g of x are defined. In a similar way, f minus g of x is meaningful only when both f of x and gx are defined. So these functions, f plus g, f minus g, these functions are defined only when f of x and gx are both well defined. So as long as f of x and gx are defined, f plus g, f minus g, f times g are well defined. So for those three some different product, the domain will be the domain of f, the intersection with the domain of g function. Now in case of the quotient, okay, yes, f of x and gx must be well defined, yes, but also since I'm dividing f of x by gx, this gx value cannot be 0 because I cannot divide any number by 0. So in order for this f of x, f over g of x can be defined, the domain of f over g will be the domain of f intersection domain. Okay, so let me, I need some more space. So the domain of f over g will be the all the x values such that x belongs to the domain of f and domain of g, and also gx cannot be 0. So such x will define the domain of f over g. And suppose that y is a function of u defined by square root of u, for instance. And u is, and I have another function g which maps x to u. Let's say u is defined by x squared plus 1. Given two functions, one function f from u to y and g function which maps x to u, I can combine. Since y is a function of u and u is another function of x, I can interpret y as a function of x by combining these two definitions. So here, y is a function of u, and this u is another function of x. So by combining these two, I can create a new function. And such a procedure is called the composition of two functions. Okay. Then, what will be the domain of such decomposition? Well, first of all, the domain of this composition and the domain of the composition of two functions is denoted by f circle g. This denotes the composition of f and g, and that is the collection of all the values in the domain of g so that g of x can be well defined. But in addition, the resulting value g of x must be in the domain of f so that f of that value can be well defined. So f of x must be included in the domain of f. So that will be the domain of the composite function. Okay, so the composite function f circle g is representing the composition of f and g. Okay, defined by this. And as I said, the domain is the set of all x in the domain of g such that this gx also belongs to the domain of f. And please note that this notation means the function g is applied first and then f is applied later. Okay, so note that f circle g is in general different from g circle f in general. I mean, in the previous example, the square root of x squared plus 1 was the f circle g, while g circle f will be f is square root of x, and then if I square that value and if I add 1, that is g circle f, and this is f circle g, and they are usually different. And in addition, if I can define the composition of two functions, why not with three or more functions? So if you have to say three functions, you can consider their compositions, and that means this notation means this one. And yeah, of course, what will be the definition, the domain of this composition of three functions? Well, first of all, x must be in the domain of h so that I can define h of x. And that value, the value of h of x must be in belonging to the domain of g function so that I can evaluate g of h of x. And then this g of h of x must be in the domain of f so that I can evaluate my function f at that point. Okay. So if you consider, if you collect all those x values, then that will be the domain of f, the f circle g circle h. Okay, questions? And I'm just okay. I this is a little bit. This is not the normal speed of the class. Usually I go a little bit slower than this, but since this is chapter one, as I said, in chapter one and chapter two, I will go a little bit fast so that I can spend more time in the later chapters. And I believe that you probably consider, you just learn these topics in chapters 1 and 2 in high school days or in middle school days, depending on your home, the countries. So, but anyway, if you think, if you miss some concept, if you want to check certain example, or if you have some questions, please email me so that then I will answer the question in the next class. And in case of the power function, so in case of a power function, we consider a function defined in this form. So you have a variable in the base and the exponent is a constant. Okay. Now, in this section, we want to consider a function of this form where the base is a constant and exponent is a variable. Okay. So base, in case of a power function, base is a variable and exponent is a constant. If your function is of such a form, then such a function will be called a power function. And we consider the several examples like x squared, x to the negative 1, x to the 1/2, right? So those were examples we considered in the previous section. Now in this section, we have a function of 2 to the x type where 2 is a constant in the base and x in the exponent is a variable. So that such a function is called an exponential function. Okay, so that is different from a power function. Oh, and if your function is say x to the x, then this is not power function, this is not an exponential function. And not power function. And we will consider that function at the end of the semester. So if I have, and if I have such function, if I have such the exponential function, then it has the graph like this depending on the value of b. And usually in our class, when I say on exponential function, this base b will be assumed to be a positive constant. So when this b is say 2, then you get this curve. And when this b is 4, you get this red one. Okay. And as you can, and if b is 1, you get this horizontal line. And all these curves go through the value 1. I mean, this point has the coordinate of 0 and 1. Okay. Anyway, so it is the first day. And let me stop here. Let's call it a day. And if you have any questions, suggestions, or anything, please let me know through the email. Okay? Anyway, let's call it a day and see you on Monday. Have a nice weekend and see you on Monday.
Thank you.